Hi, everyone. Thank you for joining the session today. Just a few words about how we will be going this way. We will discuss video processing, packaging, playback, and delivery today. And we will dive into some details. But before we start it, let's our speakers represent themselves and introduce themselves. Let's start with you, Claude.
Hello, my name's Stephen Claude Jalicy. I'm the Global Director of Streaming and Broadcast Distribution for ESL FACEIT Group, which is the world's largest esports company. I have a background in broadcast engineering. I started off doing a lot of live events, live sports, traditional stuff. Some way found my way into streaming media, live content distribution, joined ESL Gaming as it was in 2016, joined the esports world. And since then, things have grown a lot. Now, myself, my teams, we handle all of the operations, technology, strategy for ESL, FACEIT Group's esports events all over the world. Happy to be here.
Hey, everyone. I'm Neil Roberts. I am Senior Director of Live Experiences for Warner Brothers Discovery. I handle everything from source acquisition through to innovation on the platform. Previous to being at WBD, I was at Dolby. Spent a lot of time working with now my competitors to launch Dolby technologies on their platforms, bringing things like HDR, immersive audio to the public through streaming platforms. Of course, now carrying that over into the WBD space, specifically at Max. I've been in broadcast for a long, long time. I spent more time with a camera on my shoulder than anything else, and like Claude, somehow managed to jump into streaming, and we're having a blast doing it.
Cool. Hi, everyone. I'm Sean McCarthy. I'm Director of Product for the video platform at Paramount. So we're a shared service team, the Video Technology Group. We're building the platform that services a lot of the internal brands, so think like Paramount Plus, Pluto TV, CBS Sports, CBS News, international brands like My5 in the UK and Net10 in Australia. And really, we're focused on everything from signal acquisition through transcoding, video processing, packaging, origin on the live and VOD side, and then CDN and cross-platform players. So definitely pure OTT. Have a background in media, kind of spanning encoding, a lot of time in the CDN space, and then previously in like post-production. But yeah, I'll probably focus a lot on CDN and analytics, since that's been my primary focus at Paramount. And I'm looking forward to the discussion.
Sure, thank you so much. My name is Victoria Tuzova. I'm with the company Elecard, where we provide trusted video analyzers and live streaming quality control solutions. I'm also a proud member of Women in Streaming Media, where we encourage women to join the video industry. So just a brief overview of what we are going to go through today. We will discuss various formats and frameworks in media packaging. We'll explore some methods to reduce latency. We will highlight technology to guarantee high quality playback in diverse environments. And we will also examine how integrated services and integrated mechanisms such as advertising and security impact playback and packaging and delivery. So and by the way, the format will take place in an interview format, where I will ask our panelists the questions, and at the end of the session, you will have about 7 to 10 minutes to ask your questions. Sure? Okay, let's jump into the discussion directly, and let's start with video processing. I would say that this question is more for Neil. So I would like Neil to shed some lights on technical hurdles, especially if we are talking about transcoding and video preparation. Maybe you can give some examples based on live events or sports events or VOD. And the additional note that I would like to add here is about legacy broadcasting workflow.
Sure, yeah. So I think we all have problems in live where we have to deal with multiple transcodes in a pipeline, whether it's our own transcodes for different reasons or transcodes upstream of us outside of a direct-to-consumer pipeline, for example, coming out of broadcast. So at WBD, and I'm sorry, my voice is disappearing here. It's been a long show already. In any case, at WBD, we have made a lot of effort to transfer from the ground to the cloud in terms of things like master control. We're investigating cloud production. We've got our own transcoder that delivers our ABR stack to the consumer. We call it Aventus. It's a legacy iStream Planet product. And so we always have challenges where we need to get from point A to point B, where we come from site back to PCR or NOC, where we go into 2110. And from 2110, we'll hit an encoder. That's one encode. Actually, the second one, because we come back from site first. And then we head up to the cloud for our cloud master operations, where we're playing out our ads, adding SCUDdy triggers, transcoding again to come out of cloud master control. And then right now, actually, we're coming back down to the ground to do some tailoring of that content before we deliver it back up to the cloud again, where it gets transcoded and delivered. Believe it or not, I've eliminated about 4 transcodes in that process that existed before. So we're getting better, and we still certainly have a lot of work to do to get there, but certainly transcodes add nothing but latency and significantly reduce your quality as you go from point to point. Dealing with things like PCM audio was really important for us. That's one thing that we're not transcoding. We are passing that PCM audio from site all the way through to studio and PCR, all the way through to the transcoder and delivering that before we're creating our deliverables that are compressed. Audio is certainly a different story. We're not sending baseband all over the place because that becomes really difficult, especially as you go up to the cloud. But there are certain techniques you certainly can use to make that very efficient with some modern codecs, both in the audio and the video space. From a near live perspective, there are a lot of challenges that we encounter as well. One piece that's very difficult for us is that we're not just delivering direct to consumer as a company. Obviously, we've got linear channels we're delivering to MVPD and virtual MVPD partners. We're delivering to syndication partners even after our workflow for direct to consumer. They obviously also benefit from limited transcodes because when you hand that content off, it's transcoded again. So in order to represent our content as best as possible, we need to really, really get as close to the source as we can. From a near live perspective, we do shows like Real Time with Bill Maher, for example, where that's shot in an afternoon, captured live, and then played back out. And then that asset then has to have captions added. We've got to add SCUDdy pieces. We've got to get that out to archive, and it's got to go to legal distribution where they're watching it, monitoring it, making sure we're not saying anything that's not supposed to be said. And then it's got to go to linear and VOD and direct to consumer. Each one of those outputs having its own unique and different requirements for output. So very, very complex, especially as we add some of these legacy flows. But I would say the biggest thing that's benefited us in terms of quality and lower latency on our direct-to-consumer platform through Max with live sports since we've launched has been limiting that transcode and then feeding that out to my colleagues in the company who are handling our compression and distribution systems to feed those MVPD partners. We're just now starting to go back and investigate ways we can apply the learnings from direct-to-consumer in other areas that we are distributing that content.
Mm-hmm. Okay, and we will also break in this parts in the conversation as well, talking
Sure.
about more detail, having more detailed conversation in during the entire session. And of course, the next question is more about codecs and compression. So it's about leveraging, to balance between file size and video quality. I would like to ask this question, Claude, could you please help us with that?
Sure, I can try. If this microphone works.
Yeah.
I have to try and not move my fingers at all. It's pretty difficult. I'm a fidgeter. When it comes to codecs, there's actually not a lot of variety in what we do in esports, and there's a few reasons for that. There's one main reason. Similar to what you were saying before about minimizing transcoding, that's really important in our workflow. Like everything we're always trying to do, not just for latency, but mostly for quality, is try to get the content from the encoder directly to the viewer. And we want to touch it as little as possible. Like repackaging is fine and remapping audio channels and stuff like that is okay. But ideally, we want to do a first generation encode on a machine on site and then send that straight to the platform or straight to the user. The plus side of that is basically we can get very high quality, we can save a lot of money in transcoding cloud costs, especially in infrastructure costs, where we're using the public internet. We don't need a lot of bandwidth to do that. The downside to that is obviously you have to have your first generation encode be compatible with the platform you're going to send it to. So for us, we're 1080p 60 at about 6 Mbit, and we're sticking with AVC like H.264. So we're basically limited to that. Everything has to be tuned to try and make that the highest possible quality we have. It definitely is, in some ways, a limitation, but I think it definitely simplifies our workflow, right? We have a very direct intention, which is to try and make sure that the viewer sees exactly what we have created, our first generation encode. It's as close as we can get to them actually being there. They can't physically be there. We do first generation, we don't transcode it, we don't want to compress it, lose any more quality, anything like that. So we basically find out what the platform needs. So we have YouTube, we have Twitch, we have our own direct-to-consumer, we have linear partners or whoever it is, whatever they need. We do a rendition for them, a ladder for them on site, tuned to their needs, also tuned to the game. So in esports, it depends what the game is, whether it's a first-person shooter or a racing game or whatever it is. If there's high motion pixels, particles, you need to tune everything. We can tune our H.264 encode to be specifically what that platform wants, hand it over, then if they have pass-through, perfect, they can actually see that first generation encode. If they don't have pass-through, so YouTube, for example, we know they're going to transcode it, at least we can tune it to specifically suit what they're expecting, and we can basically work our way into their ladders in the most efficient way possible. Essentially, our strategy for codecs is to basically encode at step one in the codec we want at the end. That's essentially what we're doing.
Okay, okay, thank you. Sean, do you have any other comments you would like to add?
I think just following up on what both Neil and Claw said, I mean, one thing that Neil mentioned, he's H.264 heavy, across the board when it comes to D2C. That's definitely our strategy. Keep things simple. We want to do more device targeting. We'll get into that later, so I won't dive too deeply into it. But there are definitely some challenges with that. We'd like to roll out AV1 and HEVC a lot more, maybe even VP9. But it's more of a legacy device problem and device targeting problem than it is, just generating the transcode. But in terms of keeping quality the highest possible, yes, we want a MES file as close to the source as we can. We want to do one transcode. We want that, we're fine with packaging multiple formats out and caching them. But when it comes to, partner distribution, one thing that maybe it's unique to us, we have fast first services, so like Pluto TV. A lot of the channels that we launch on Pluto are actually built on top of just pure HLS. So we're not transcoding, MES streams. That works fine, and it's actually very economic for us and easy for us to build a playlist, send it out D2C over our app, and we always think in terms of our platforms first, our direct-to-consumer platforms first. But there's more and more partner distribution happening. Mm-hmm. They don't want necessarily RHLS. In some cases, they won't take it. So our big challenge is not necessarily multiple transcodes of various intermediary formats or MES formats. It's HLS back to a MES stream, and that's pretty challenging. And that's really, like I said, to service the distribution partners. So it's the distribution ecosystems that's causing us the biggest headache. I think it's pretty straightforward for our direct-to-consumer.
Mm-hmm, yeah. Mm-hmm. Thank you so much. And Claw, the other question for you, because during the preparation call we were talking about GPU and about the point, the efficiency and from efficiency perspective and from scaling perspective. Could you please share your comments here?
Sure, I'm going to change hands. Sorry, everyone. That wasn't too bad. That wasn't too bad, actually.
What is the role of GPU?
Come on. GPU for us is actually pretty important, but it's really got nothing to do with the quality of the video. It's all about density, basically. And essentially, we don't expect when we do a GPU encode over a CPU encode to see any quality difference or anything like that. It's basically what I talked about before, our strategy about trying to do everything on site. Our goal is we never want to backhaul like original source quality, really high bandwidth content. We essentially just want to do everything on site, cater it specific for platform, and send it off. And when you're using a GPU, you can then get a lot more density. You can do a lot more on a GPU before you hit a threshold where you can't encode anymore. So that's really the most important thing about the GPU for us is rather than any kind of gain we expect anywhere else, or it's just about trying to squeeze more onto site with less hardware. We can essentially use consumer hardware that you can buy anywhere and then just put a really powerful GPU in it, a few GPUs in it, and then just do a lot of transcoding, create a lot of ladders, a lot of unique encodes, and do all of that from something that's relatively inexpensive, very small footprint. I think when it comes to upscaling 4K, stuff like that, it's a little bit different because when I talk about a high resolution stream in esports, that's still 1080 because there's 1080p 60, good 1080p 60, and there's bad 1080p 60. So we're focusing on good 1080p 60. At the moment, that's still what we think is more important than 4K or anything higher than that. I think 4K at the moment is still very much showcase, right? We don't think that we're going to gain any viewers from having 4K. We don't think we're going to lose any viewers from not having 4K. So it's all about how much 1080 can we squeeze into one encoder and how many renditions can we do and send those off. So I think GPU is very important to us for density, but not so much important right now in terms of we need it for 4K workflows or upscaling or 8K workflows or anything like that.
Okay.
I'll say GPU is absolutely critical for us in our workflow. Our transcoder, like I said, it's a home-built, homegrown transcoder, and especially as we started getting into HDR, all the HDR processing had to be done in GPU. And we couldn't then copy from GPU to CPU and back to GPU. It just was super inefficient. Then the other problem that we did have is that some of the SDKs that we started implementing for processing that HDR were not optimized or even ready for GPU. So we actually had to rewrite some of the code we were getting from some of our partners in order to operate on GPU. And that makes things really difficult when we have to go back and upgrade an SDK. We have to rewrite it again. It becomes very, very inefficient. So we have had to work really, really hard with some of our partners to implement those technologies and ask them to write, CUDA kernels and things like that fits in the GPU so we can actually do HDR well. We also are a 1080p 60, 1080p 50 house, depending on where we are in the US. We'll talk about that a little bit more, but yeah, so I mean, we do 4K, but to your point, you have to be in that GPU space to really get there.
Yeah, I'd add the same. I mean, our strategy for GPU is more driven by what Claude mentioned around density and economics. We want to stream we want to be able to transcode as many streams as possible using as little hardware as possible, as light a weight cloud resources as possible. We do also want to future-proof for 4K and HDR formats. We're not doing a lot of that today, but the GPU transcoding will help us get there. It's actually been a theme for us this year at the show. We've been talking to different GPU vendors. Our challenge is we're doing all of this in the cloud. So we're beholden to basically three. There's a lot of flexibility the cloud offers, but we're essentially beholden to three entities, right? It's the cloud provider. Do they offer the GPU that we want? Do they offer any GPU? The software we're putting on top of it, right? We're not writing our own transcoder. Does the software play nice in that particular cloud environment? Does it play nice with that particular GPU? And then, of course, the cloud provider themselves, are they offering us the rates we want? Do we have a preferred cloud vendor? Can we work with them to get the GPUs that we want installed? So yeah, I think that getting the right balance of the encoding software, the right GPU partner, and the right cloud vendor is what we're currently looking for. We're trying to move away from locked in sort of SaaS offerings and kind of build that correct mix, put it in our own Kubernetes cluster, manage it ourselves in our own VPC, but we're not going to be doing this in our own data centers. So we have to work with those providers to create that.
It's not easy.
Yeah.
Okay, thank you. So Neil, this for you. It's about packaging part. So the question is just to get into more details about preparing media content for distribution, if you're focusing on adaptive bitrate streaming.
Yeah, so we deliver HDR, we deliver Dolby Vision today for all of our sports that we're creating in the US out of our Techwood facility in Atlanta. And just because we're delivering HDR doesn't mean everyone can consume that HDR. So we still have to deliver an SDR variant of that HDR. Same goes for audio. We always have to deliver a stereo AC, or at least have it to offer, even though we're delivering stereo DD+, 5.1 DD+, and DD+ Jock or Atmos. So we also have to think through things like manifest filtering, manifest selection. How do we get the right rendition, the right version to the right device? Are some devices not capable? Are they low horsepower? Are they having poor network connectivity? Getting all that back, building filtering lists for low-end devices that just can't handle certain things, even though they claim to be 4K or HDR compliant or capable. Sometimes what you give them just doesn't work, right? So it's really trying to leverage some of the services that we have and some of the things we've learned from our legacy HBO Max days and Discovery Plus and all the things that we know weren't possible on those devices. And then as new devices come, we even still find limitations. So manifest filtering is a really, really big thing. And making sure through those services that we're delivering the appropriate services and codecs and all the fun stuff that comes along with that to each one of those devices can be really complex, but we have built a pretty good decision engine that's been very efficient for us in order to deliver a very consistent and premium experience.
Okay, thank you. And talking about the very close question for Sean is like delivery content across the different platforms. So could you please share your experience here?
Yeah, I mean, device fragmentation is definitely a challenge. You hear it, it's something we deal with day to day. It's the device fragmentation that not only makes it more difficult, time-consuming, and resource-intensive to build and deploy our apps across devices, but in order to take advantage of things like codec targeting or manifest generation or filtering of some sort, maybe we want to expose HDR renditions to some devices and not others, multi-language audio to some geos and not others. That's a little bit of a different manifest manipulation problem, but the idea of geo-targeting and device targeting is something we're working with and we're constantly developing solutions for. The biggest challenge on the device targeting for which formats to send or not send is not necessarily, it's similar to what Neil said. It's when devices expose certain specs or support for certain things like 4K support, right? Well, we don't know necessarily if just because there's a Roku 4K, if there's a 4K monitor, right? So then we want to be able to get closer to the hardware, maybe extract some information from the EDID, to see what actual monitors connected to that HDMI cable, through the HDMI cable. Doing that across all devices at scale, A, it's not possible on all platforms, but B, it's a challenge. It takes time. HDR support, same thing. You can have an HDR compatible device that's not connected to an HDR compatible monitor. And then when we talk about like international expansion, just the number of devices out there and the really esoteric devices make it very challenging. We have devices that supposedly support certain codecs or certain formats like 4K. We send them a 4K stream and they'll choke on it. Our app will crash. Or if not, the battery might drain, on a mobile device in minutes, and we don't want that sort of experience for our users. So creating that correct mapping of, device to format support, making sure it's comprehensive, and making sure we're getting enough granular information from the device itself, maybe decoder information, or like I said, the EDID sort of monitor and screen information is pretty important.
We've had issues in Latin America in particular, where there's like this weird gray market for buying Android devices, and there are no Google Play Store. So people are literally sideloading apps onto these devices, and those devices are claiming to be tablets, but they're actually DMEs. Yeah. Right, and so they're downloading the wrong thing, and then we're getting blamed because the device is misrepresenting itself.
Right, and there's security implications.
Oh yeah,
too.
100%.
So we talk about device targeting and all this. One of the other things we're trying to do is recognize compromised CDM devices or compromised DRM devices with DRM vulnerabilities, and if not block the streams outright, and this maybe touches on another topic, so yes. I'll wait on this, but if not block the streams outright, at least use it as a vector of piracy to paint a picture of fraud.
Right.
And in order to do that, you have to be able to track the device level information. So yeah, device fragmentation, I think, is the kind of the precipice that makes it very, very challenging.
Mm-hmm. I'll add to that, adding complexities around dynamic ad insertion, right? Especially when you've got a device that says, yeah, I can do HDR, and you're giving it an HDR stream or a 4K stream, you have to deliver the ad in the same format that the content's being delivered in for a consistent experience. If it's not representing itself correctly, then the ad revenue is lost as well, right? So it's just a terrible experience all around.
Yeah, absolutely. Regarding the piracy, we will circulate back to this question just sure. a few minutes later. And now I would like to ask Chloe about the question about the venue and about the production side. Like maybe you can share some, I would say, techniques or methods to maintain audio and video creative intent from production, from venue to the end user.
Sure. I would say what that means to me is basically kind of what I've touched on in every answer I give, mm-hmm. Which is basically about giving the viewer exactly what we intended them to see, right? And I think what you see on a lot of traditional sports, it's all camera work, and you can be a lot harsher with the encoding, and you get a lot of transcoding, and you get a lot of different versions, and depending on what platform you're watching it on, it can be degraded. We're always trying to make it look the best it can, right? And for us, that's the first generation encode we talked about. It's on site. The encoder is physically there. It's baseband video in, like 3G video, and then we're doing our first encode, and then we want to try and keep it there. Like that's essentially everything we do in our workflow is geared towards that. Essentially, we're doing a little bit now of our own direct to consumer. It's more of a lean in experience, whereas what we have on Twitch and YouTube is more the lean back experience. People are just watching the tournament. What we're focusing on there is basically trying to get them the content as fast as possible and as high quality as possible. Everything we do is based on that. There's no decision in our workflow that is for any other reason than that single purpose. Essentially, frame rate is very important, resolution is important, but not as important as the frame rate. Just the perceived quality is the most important thing. Okay. So in terms of they can't be sitting in the chair looking at the stage, but when they watch the stream, it needs to be as close as we can possibly get it to the game, right? So if they're playing the game on their PC at home, they have a perception of how that should look, because almost every esports viewer is a player of the game. We need to get as close to that as possible. So in terms of preserving the intent of our content, like that is really what we're focusing on. We're never going to actually have our encode, or not at the moment have our encode match what they can just see on their own computer, but that is the intention. Basically, no transcoding, no extra encoding anywhere else in the workflow. Just try to get it from the encoder into our platform, which is just purely for repackaging and routing, and then get it straight to the viewer.
And how about your approaches? Do you have any
I have
comments
spent
here?
the last 6 years of my life maintaining creative intent. It is not our job to create that content. What we need to do is deliver that content correctly. There is someone else making creative decisions, and they're being paid a lot of money to shade cameras, to mix audio. The colors are supposed to be correct. The skin tones are correct. If you're watching sports, much like esports, you know what color your team's jerseys are. You know what skin tones should look like. You know what the ads are supposed to look like for the products and the ads. So I have developed a process that we refer to as 3-up, which allows us to essentially, the first up is up-resing. So really for us, it's de-interlacing, where we've got interlaced content to deliver 1080p 60. Up-mapping correctly to HDR from SDR, if that's how your content is derived. And if not, it's HDR and you're passing that through, and that's great. We apply dynamic metadata through Dolby Vision and deliver that as Dolby Vision because we know exactly how that content will be presented on the consumer display. And the third up is up mixing. Really what we need to do in order to maintain that creative intent and take control is take control of the consumer device. We don't have control of that device, right? There are a million things a consumer can go and manipulate and change in terms of picture quality, audio settings. So we need to pull that back in, put things in the largest possible container we can, and take away the assumptions of those displays or those devices in the consumer home. The only way to do that is by, like I say, placing them in those large containers. There's a ton of standardized practices in order to get there, but there's no reason we shouldn't be delivering an absolute premium experience. And if you deliver SDR to a consumer display that's HDR capable, for example, that display is going to stretch the hell out of that content, and it's going to do it wrong. So if I want to deliver it correctly, I'll put it in that larger container. We're monitoring that, and we can be assured that that device can no longer manipulate that content. So for the first time ever, if it is SDR content that we're deriving from, that's not my decision. That was the creative's decision to create that content in SDR. I just need to deliver it correctly through these mechanisms.
Yeah, I mean, completely agreed on maintaining creative intent and creative integrity of content. A lot of the issues Neil brought up are a little bit removed from our team's world at Paramount in terms of de-interlacing, frame rate conversions, and sort of the normalization of content in that regard. But HDR is very challenging, and specifically for live. So, we recently did a really big sports event, and we had an HDR stream. In testing, for that event, there was issues around, color space conversions, doing, PQ conversions upstream before the video is actually handed off to us for transcoding for direct-to-consumer distribution. And one of the reasons we targeted a smaller amount of devices than we originally planned was just because of the way certain devices were handling the HDR, and certain screens, believe it or not, smart TVs were actually displaying the HDR. We had pink hues where there shouldn't have been. And, Dolby Vision, I think, on paper that it solves a lot of those headaches and a lot of those problems. We didn't do Dolby Vision, but I think that when we're talking about maintaining creative intent exactly as, the creator intended throughout the chain, Dolby Vision and passing this metadata through HDR10+, I mean, that's the point. I think that's best practices. Doing that at scale for a large event and targeting a lot, many different devices is very, very challenging.
Yes.
I mean, we had people, looking at different screens, debating whether or not there was, lens flares or it was, an issue with the encode. And one thing that we learned in that process was the need to monitor and actually decode the video and do perceptual quality analysis at various points in the chain. And there are a lot of vendors that offer different tools to do that. You don't necessarily need to go overboard and actually unpackage and decode and inspect the content at every handoff point, but there are some very strategic ones that in a live workflow you should. Pre and post transcode, post packager, and then for us it was the PQ conversion. Was a very important kind of pre and post perceptual quality point in the workflow.
And the other blood boiling question is about latency. We just discussed it with Neil. That's just like a key word for the industry right now. And the question is related more to the reference point here. So whether the standard for measuring latency in media delivery should be based on the timing of broadcast or by the timing of action or live event. So how to measure it in the right way. Maybe you have some examples for live events or maybe the, I don't know, World Cup, esports tournaments, or like Super Bowl tournaments, any specific cases that you can rely on in this, answering this question?
I think both measuring from live and also comparing to a broadcast as reference are both really good points of measurement. Of course, we all want to be as close to live as possible. Yeah. For many, many reasons, that's very difficult. But I think you can take things in phases too, right? So I'll be honest, we actually favor quality over latency. Yeah. And I think that it's a little bit of give and take for sure, but as you get into much lower latency, you sacrifice quality. So it is finding that balance, I think, of the two.
Yeah, latency is not an issue. It's not something we're concerned about. It's not what's driving our discussion. We don't have business KPIs to lower latency. Will that change in the future? Possibly. You know, with standard HLS and dash, when we do a large event, we do minimize our segment sizing. So just going from like our standard 6-second segments, 6-second chunks down to 4 or 2 seconds really does cut latency. That's good enough. I mean, we recently did like a really large event. We handed it off to multiple MVPDs, and you know, we definitely had, as a direct-to-consumer platform, the lowest latency relative to broadcast. That's how it was measured. Just going back to your question, it was relative to broadcast, not, you know, relative to live action, you know, on scene. Yes. It's not a concern. It doesn't come up in any discussions. Now, I will say, the way that I would think about solving the problem going forward, because it's not only potentially solving a latency problem, but also solving several other problems, such as last mile internet congestion and an easier way to synchronize playback. So like synchronicity across players is actually probably a lot more important to us than lower latency, but that would be media over quick. We're not doing it today. The internet's not ready for it today. The device landscape isn't ready for it today. But if I were tasked with solving the problem of latency, hitting a target latency, I would be very compelled to innovate around MOC, media over quick. There's a few vendors, you know, NAB this year talking about it, but it's got all of the benefits of WebRTC with that real-time streaming latency, with the flexibility and ability to target your standard HLS and dash and OTT formats. Like I said, internet's not ready for it, but that is definitely the bet that I'm going to place if we ever get you know, tasked with more real-time streaming or very low latency.
Chloe, how about your case?
Yeah, I mean, I would just echo what they've already said, and I think latency is definitely not, we don't perceive it as a problem in esports. I think there is a couple of differences between traditional sports and esports where we don't prioritize traditional broadcast at all in our workflow. Whereas, I mean, traditionally you would do your broadcast for TV and then you bolt OTT onto the end. And now it's not as bad as that, I think, in most cases, but you still have a very separate workflow, and you're backhauling all the content, you're doing whatever you need to do for your partners, for your channels, and then you're distributing for OTT. Everything we do is OTT first. So originally, before we had our own direct-to-consumer, that's just Twitch and YouTube. They've put a lot of work into making their platforms really, really good all over the world. Like, we expect the time from what someone's sitting in the venue in their chair seeing to what our viewers see, we expect that to be within 10 seconds. And in all of our measurements, that's realistic. Twitch and YouTube do an amazing job there. With our own platform, we're benchmarking against that, basically. We're talking about live to viewer at home, but that's an OTT viewer. So everything is done for OTT, and then we synchronize everybody up for that. So if we're broadcasting on normal linear TV, we would basically have our workflow set up for OTT, and then we align them with that. So there is no real difference for us between a traditional TV broadcast and OTT, just because we prioritize what would normally be at the end of the chain first. And that's how we approach that.
I think there's low latency, and ultra low latency, right? Lower latency is where we're at right now, because we are lower latency than an MVPD or a virtual MVPD partner, and we don't have any OTT or OTA comparisons that we can do, because we're a cable, linear, or direct to consumer. But again, it's so critical to not bolt on your direct-to-consumer experience to the end of a legacy broadcast experience, because you will not be faster than that at any point. You have to reimagine your workflow.
Yep. Get as close to the source as possible.
Absolutely, yeah.
Sure.
No, I mean, that's like I said, latency isn't necessarily a problem we're trying to solve, but I mean, it would be impossible to solve it with the current workflows for certain live events. We do a lot of like international sports. We'll acquire a signal in Australia or Brazil, transmit it, for U.S. distribution on OTT. There's no physical way we could be faster than broadcast in that regard if we're taking the handoff from the satellite. Do we have to deploy boxes on site at all these, for mezzanine encodes, for all these events? I don't know how scalable that is, especially if we're licensing this content from third parties and not necessarily producing it ourselves.
Yeah.
So, there's a lot of people that would have to be involved to tackle, that particular latency problem. But even just on the OTT side of low latency dash, LLHLS, chunk transfer encoding, and we're not deploying anything like that. It hasn't been a need for it.
Yeah, I think that's like the main takeaway I have, and definitely when we talk about esports, that's what I'm always saying is people ask us how we deal with latency, how we solve the latency problem. I think my answer right now is that we just don't perceive there to be a problem that needs solved. Essentially, even when you're talking about Twitch and YouTube, they're super fast. But even in general, we have different platforms that are slower than that. There's really no sense from us that the audience cares about this, in terms of nobody is watching two different platforms and comparing them and complaining that one is faster than the other. It just doesn't seem to be a problem.
We do that.
Yeah, exactly.
And it's like, we should stop doing that and talk about bigger problems, because like every time we do that, it drives a lot of the discussions like here, drives discussions out on the floor when we're talking with vendors, but not a huge challenge.
Yeah, that's absolutely true. Like the only people you're going to hear talking about the gaps between TV and OTT or the arena and an OTT platform is people at a convention like this. The audience doesn't care.
That said, it's not acceptable to be at a minute of latency. So
yeah, of course, within reason.
That's a good point.
Yeah.
It's just standard.
It's best
and
effort,
Dash
right?
are offering us the latencies that we need.
Okay, circulating back to problems. How about piracy?
Yeah, it's a big topic. Assessing the scope and the impact of piracy, assessing the scope and the landscape of like how much piracy is happening and what kind is kind of the stage we're at. We're not necessarily trying to brute force with all of our resources stop it. If we did, it would be very much kind of a whack-a-mole type attempt, killing different sessions, revoking access to certain users. But generally speaking, DRM studio mandated. It works a lot of the time. There are vulnerabilities. Widevine. There are Widevine hacks. There are compromised, CDMs. There are ways around. There are certain pieces of hardware where you can decrypt encrypted content without valid keys. This stuff happens. We're at a stage where we're really just trying to assess what is the scale at which this is happening. Is this really going to move the needle on subscriber counts, on legitimate signups? If we go after potential pirates, is it going to correlate with legitimate usage, an increase in legitimate usage? Then these discussions oftentimes get, I don't necessarily want to say conflated, but there's a lot of different pieces to it. So there's credential sharing. There's bypassing geo rules and geo blocking. If we have the rights to stream a soccer game in the US, but not in Italy, and all of a sudden there are users in Italy and the league catches wind that they're consuming Paramount Plus content where they shouldn't be, we can be held liable. So those are more of the discussions with the content licensees that are driving the piracy, the need to address piracy more than increased costs or our concern about subscriber numbers, or et cetera. Now, I don't know, how deep we want to go with it, but essentially, the way that I've been thinking about this problem is not to say, just throw DRM on it. We need more aggressive key rotation. That's one way to address certain vulnerabilities. But if we're going to just assess the landscape and quantify how much piracy is happening, we need the data. And my approach has been 3 data sources to correlate, technically 4, but it's CDN logs, not metrics, raw access logs, because we have each and every individual request that comes from a client, whether it's a legitimate client or an illegitimate client, a GET request is logged there. Client-side beacons, analytics, and DRM server, license server logs. My approach, it's been kind of heavy-handed, but if you have a way to handle that high volume, high cardinality data in an economically feasible way, a cost-effective way, you can derive really, really insightful patterns of behavior. Look for, non-organic, request patterns. Look for too much bandwidth coming from a particular user IP address. We catch residential proxies being used as, VPNs. The VPN services that are charging us for VPN detection can't even catch them. There's a lot of data out there. And as an industry, we had to think about, how we can make better use of it, and not just wait for some vendor to, solve the problem for us and sell us something. We have a lot of it. We just need to be able to access it and derive the right insights.
Sure. Any other comments?
No, he definitely hit all of it.
Perfect, Sean.
The only thing I would add for esports, because it's a little bit different, is all of our content is free. So when you ask us about security, piracy protection, it's a totally different discussion because we just don't care, right? Essentially, we want the content everywhere. If you're stealing it, if you're restreaming it, great. Essentially, all we're trying to protect is more on the production side and obviously regional exclusives of content. But even then, we don't mind so much if, essentially, as long as the different regions who have the rights to do their own show, their own content, their own language, as long as we protect that, essentially the spreading of content is actually something that we look for, right? Our content is always free on Twitch and YouTube in English. Anybody in the world basically can watch that. So our business model is very different, and that makes the need to protect our stuff from piracy much, much lower. Even on our direct-to-consumer, it's a completely different model, basically, where esports is just traditionally never paywalled, and there's very few, geo-blocking as well is not really a thing. So technically, it's an area we don't focus on very much at all.
I'm super jealous.
Yeah, but that's a good point, because content type matters. Premium content we're going to want to secure and lock down more than free content. But even on our free content, fast content, let's say, it's ad-driven revenue. You would think that no one would steal a fast stream if they could just log on and get it for free. Most of the time, that's correct. That's why the fast services are growing at the rate they are. But geo-blocking is the reason they would. You want a fast channel when you're out of country. you're going to try to get that and access it, in an illegitimate way. That's lost ad revenue. You're paying for, the CDN bill. You're, in some cases, and this is more on less on the viewers consuming pirated content, but more on the bad actors sort of setting up third-party sites. They're actually stripping out ads in certain cases and, remonetizing the content and setting up, is that happening at a point that we've decided to go after, like I said, with all our resources? No, not yet. But we don't want to become the music industry. So, what the music industry was before, Spotify and some of the streaming services. So it's something that we're definitely aware of.
Yeah, that definitely is a very important point, actually, because I joke that we don't care at all, but obviously one of the main areas that esports is being monetized is through ad revenue, right? So that is definitely something that we do focus on. If the content is spreading, that's great. But if it's not burnt in ads, if it's not burnt in sponsorships, and they're stripping that, then that obviously is a problem, and we have to find creative ways to try and make sure that the content doesn't go there.
Yeah.
And we have limited time here, so maybe summarizing, I would like to ask you the final question more about delivery side, about quality of service, quality of experience parameter that you monitor to check the performance, which data you think is seem reliable for you, and what role does it play at your workflow?
Let's start with that one.
Yeah.
Yeah. So
you can take the floor.
The industry standard sort of client side QoE telemetry is kind of the starting point that we assess the end user experience with. And the metric that we would probably weight most heavily or look at, most often is a combination of video playback failures, video start failures, and connection-induced rebuffering.
Oh yeah.
Different vendors of different analytics offerings might name those slightly differently, but what we're really talking about is, did something kill my playback experience? Did my player crash, or did I experience a rebuffer, or was I never able to start the stream? We're not looking at video start times too much, and there are a lot of nuances with video playback failures. So there's some work being done right now in the SVTA, actually in our QoE working group, to kind of normalize some of the player error codes to make getting to the root cause of playback failures a bit more approachable, reduce that time to diagnose issues. But QoE definitely matters to us, and one thing that maybe it's a little unconventional, but I think it's going to become kind of steady state in the next couple of years, is really leveraging CMCD data. So it's a common media client data to be the new sort of industry standard reference of buffer health, playback health. One of the things specifically we're doing is trying to translate more nuanced data fields like buffer length, buffer starvation, into what we're calling a buffer health score.
Okay.
It would essentially be a 1 to 100. How healthy are my client buffers? Are they getting the best bit rates that they can in a given region? Now, once again, these are problems that client-side analytics providers are solving. I think there's an industry standard kind of push right now to maybe leverage CMCD to derive some of those metrics. So.
Okay.
I think equally as important is how users are actually using the platform, right? Not so much how are they clicking to find things, but are they receiving the codec we expected them to receive? How many people are receiving those codecs? And then starting to look at those numbers, for example, across March Madness, how many people watched HEVC versus AVC. And for us, we deliver AVC through SDR, or SDR through AVC, and HDR through HEVC. So it's really easy for us to see how many people are watching what they're watching. But then we can start leveraging that data to say, okay, maybe we should actually be delivering SDR in a more efficient way as well. So we can go back and look at those things, those metrics, and actually tailor our future experiences based on how people are leveraging the platform overall. That's
actually really important for us as well. And now that traditionally we were just doing Twitch, YouTube, we were handing that off to our partners, and all the QE is basically their problem. Essentially, we would just have the users themselves to answer to, because esports is always hand in hand with a live chat, so you get flamed pretty hard and you always know exactly what they think. But now that we're doing our own direct-to-consumer, everything you just said is super important, because our direct-to-consumer is a lean-in experience. It's multi-view, you can follow different players, you can assemble your own broadcast. And what the users are doing is obviously one of the most important things to us. Like, we want to know exactly what they want so we can cater to that experience, because that's a more hardcore viewer and not your mass audience.
Sure. Thank you. We are running out of time. We're just in time. So if someone has any questions, please feel free to ask your questions. Now we have some time for that. Okay. Just one question that I have, that I asked my colleagues what they would like to ask you after the session, and they told me that they would like to ask you about the general overview. What you think is the most significant advancements in the industry over the past years? Tricky one?
That's really difficult to answer.
Or maybe that's something you are waiting for to advance the industry.
I don't know. I wasn't prepared to answer that question, but I will say, and this is maybe just because it's top of mind because of some conversations we've been having, this week. But two things jump out. One is the significance of cloud transport. Zixi seems, not to pick winners or anything, but Zixi seems to be becoming an industry standard. I think there are reasons why, and I think that's going to facilitate a lot of innovations beyond just partner distribution and contribution, but also production in the cloud, and really making it possible to, virtualize some of the media workflows that we're talking. I think that's pretty huge. SRT just as much. I only say Zixi because I think it's becoming, based on some tooling, they're becoming kind of an industry standard. Another thing, and I don't know if this answers the question directly, it's, look, everything for us, it's a cloud-first world with these technologies. And what we've been doing kind of strategically in our kind of philosophical approach to building our video platform is to recognize that winners and losers come and go. Like best-in-class vendors, or from a couple years ago, aren't always going to be the best, in a year or two. And as such, we decided, okay, if there's a service that requires very particular business logic for Paramount, we'll probably build it in-house. But a lot of things don't. A lot of things are commoditized. But we don't want to be beholden to one particular vendor, integrate with their APIs directly in our workflows. Instead, we want to build orchestration layers. We want a vendor-agnostic approach to anything that we build and that's integrated into our apps. So as a central service team, we're building APIs, software layers that abstract and orchestrate in a sort of a plug-and-play manner, different vendors, so you can build workflows. And it's our APIs that the different brands and apps, that we're building are integrating and consuming. So if we want to swap out transcoding vendor A with B, there's some legwork to do it, or CDN vendor A, B, and C, like, we're able to do that. We're focused on building scalable, reliable orchestration layers, and then finding the best-in-class vendors to partner with.
Okay.
I think, I don't know what the number one thing is that we're waiting for, but I think I'm thrilled to see how quickly advancements in the cloud space have come. It's really saved us in so many ways, not just financially, but headaches from a workflow perspective. Yes, it's introduced some, but once you get a handle on that, it really just opens so many doors that that weren't open for us before, and I'm super excited to see how that evolution continues.
Sure.
I would just jump on the back of the first thing Sean said, where I think it's like one of the most important things, I think, in esports. Everything we do is on the public internet, right? Like all of our transport has always been IP, if you want to call it that, like, but over the public internet. And I think that's something that people still, like in 2024, are talking about being the future. For esports, it's now, and it's been that way for at least 5 or 6 years. So I think that's definitely one of the most exciting things. I think it'll be really interesting as traditional broadcast, traditional sports starts to go that way, because I think it's absolutely inevitable, right? The amount of money that we invest into an event and invest into the infrastructure for an event is just so much less than you would in traditional sports. And I think now, you know, it's 5 nines reliable. There's no real reason to not do it anymore. You just can't justify satellite or really big, heavy infrastructure. There's the reasons to do that are just dwindling. So I think that's going to be really interesting to watch happen. Basically, I think we're right at the front in that territory in esports, and it's going to be really exciting watching everybody else kind of do that, but on the highest level, you know, on the biggest traditional sports productions.
Thank you, everyone. Thank you for joining us.